Hey there, and welcome to our channel. Are you a grade 8 student in Kenya studying CBC Rationalized Integrated Science? Then this video is for you. We're going to be introducing our brand new demo PDF ebook with audio embedded, specifically designed for the CBC curriculum. In this video, you'll get a sneak peek of what the ebook looks like and how you can use it to boost your learning. By the end, you'll be itching to get your own copy. So buckle up and watch till the very end. Important note, we won't be including the purchase link in the video itself, but you can find it in the description below. Let's jump right in. Elements and compounds, the building blocks of matter. Matter is anything that occupies space and has mass. It can be made up of pure substances or mixtures. Pure substances can be either elements or compounds. An element is a substance that cannot be decomposed into simpler substances by chemical or physical means. It's the basic building block of matter. Everything around us is made up of elements, either singly or combined. An element is made up of tiny particles called atoms. All the atoms of a specific element are identical. Now, sometimes elements like to get together and form something new. When atoms of two or more different elements chemically join together, they create a compound. Compounds are pure substances made up of atoms of two or more elements that are chemically joined together. They're formed when atoms of different elements react. Unlike elements, compounds can be broken down into their individual elements through chemical reactions. For example, sodium and chlorine are elements that combine chemically to form sodium chloride, a compound known as table salt. Remember, mixtures can be separated into their components by physical means, while elements and compounds cannot. Molecules are groups of atoms bonded together, and can be elements, like oxygen gas, or compounds, like water. Relating common elements to their symbols, a simplified explanation. Our world is made up of tiny building blocks called elements, each with a unique name and symbol for easy identification. Think of these symbols like nicknames for the elements. Why symbols? Using symbols instead of full names is much more convenient and quicker for scientists. Just like you use H2O instead of 2 hydrogen atoms and 1 oxygen atom to describe water, symbols help communicate complex information efficiently. How are symbols derived? Most symbols come from the element's first letter in English. H for hydrogen, the main ingredient in water. O for oxygen, essential for breathing. C for carbon, the building block of many living things. But sometimes, symbols have a Latin origin. K for potassium, named after Kalium in Latin. Ag for silver, derived from argentum in Latin. Sharing letters. When multiple elements start with the same letter, the first two letters are used. C for carbon, Ca for calcium, Cl for chlorine. Remember, the first letter of a symbol is always capitalized, the second is lowercase. Symbols are a powerful tool for understanding the world around us, from the air we breathe to the materials we use every day. Bonus. Let's explore some common elements and their symbols. Element name. Symbol. Example. Hydrogen. H. Water, hydrogen oxide. Oxygen. O. Water, hydrogen oxide, air we breathe. Carbon. C. Graphite, diamonds, living things. Nitrogen. N. Air we breathe, proteins in our body. Sodium. Na. Table salt, sodium chloride. Magnesium. Mg. Bones, muscles. Iron. Fe. Hemoglobin in our blood. This explanation avoids technical details while conveying the core message. Elements have unique symbols for easy identification and understanding, derived from their names or Latin roots. Remember, the goal is to provide a clear and engaging introduction for students, not an exhaustive list of facts. Understanding the building blocks of life, elements and compounds. Imagine the world around you built with tiny Lego bricks, much smaller than any you've seen before. These bricks are called elements, and each one has a unique name and symbol like a secret code. Think of H for hydrogen, the main ingredient in water, and O for oxygen, vital for breathing. But sometimes, these bricks don't play alone. Sometimes they team up to create something entirely new, like a giant Lego spaceship. These new creations are called compounds, and they have their own special code called a chemical formula. It tells you exactly how many of each kind of brick are used. Let's use familiar examples. Water, hydrogen oxide. Think of a refreshing glass of water. It's made with 2 blue bricks, hydrogen, and 1 red brick, oxygen. Table salt, sodium chloride. This salty seasoning is created by 1 blue brick, sodium, and 1 green brick, chlorine, teaming up. So, how do we understand these codes? A chemical formula shows the elements in a compound, like a recipe. Numbers after the symbol tell you how many of each element are present. By understanding these basic rules, you can unlock the secret language of elements and compounds. Here are some key points to remember. Compounds are always made from 2 or more different elements. Chemical formulas help us understand the building blocks of any substance. Elements can combine in countless ways, creating all the amazing things around us. From the air you breathe to the food you eat, everything is made up of these tiny building blocks and their amazing combinations. So next time you look at the world around you, remember, it's all built with tiny Lego bricks called elements and compounds. Application of common elements in our day-to-day life. Food nutrients. Chemical compounds for health. Food nutrients are vital chemical compounds found in various foods, essential for proper bodily function and maintaining good health. Building blocks of life. Examples include proteins, meat, eggs, legumes, fats, nuts, avocados, olive oil, carbohydrates, bread, fruits, vegetables, vitamins, and minerals. Elements at play. These nutrients are made up of various elements like carbon, present in all foods, nitrogen, meat, poultry, eggs, calcium, milk, cheese, leafy greens, iron, red meat, beans, leafy greens, and potassium, bananas, vegetables, milk. Various food sources of key elements. Mineral element, compound. Examples of food sources. Carbon, present in all foods. Nitrogen, meat, chicken, fish, milk, eggs. Fluoride, fish, potatoes, spinach, black tea. Calcium, milk, cheese, green leafy vegetables, soybeans, bread, fish. Copper, nuts, shellfish. Iron, liver, meat, beans, nuts, whole grains. Magnesium, spinach, bread, fish, meat, dairy foods. Phosphorus, red meat, dairy foods, fish, bread, rice. Potassium, bananas, vegetables, milk, fish, beef, chicken, bread. Sodium chloride, salt, naturally present in low levels in all foods, added to processed foods and meat products. Plants and the soil connection. Nutrients from the ground up. Plants receive water, minerals, and other nutrients from the soil, which are then transported throughout the plant. Essential elements for plant growth. Important mineral elements absorbed by plant roots include phosphorus and magnesium, growth, development, reproduction, and potassium, improving fruit and vegetable quality. Elements in everyday toiletries. Fluoride for healthy smiles. Toothpaste contains fluoride compounds to prevent tooth decay. Potassium for cleanliness. Soaps and detergents contain potassium compounds for cleaning and removing dirt. Remember, elements and their compounds play crucial roles in various aspects of our lives, from nourishing our bodies to maintaining hygiene and building our environment. By understanding these connections, we can appreciate the fascinating world around us and make informed choices for ourselves and the planet.